All right. Good day, everybody. My name is Esfandiar Kuhi. I'm Simulation Product Manager at Intercat. And today webinar we're talking about Trend Tracker as one of the features in SOLIDWORKS Simulation. All right. Before we go into this specific feature, let's have a look about SOLIDWORKS Simulation Solution. We have a complete product simulation solution. Well, the first category is going to SOLIDWORKS Simulation FEA, Finite Elements Analysis, and in this category we are able to do the structural analysis either on a single part or an assembly or big structures. We are applying loads and we are looking in the stress, strain and displacement result to accept or reject the design. In the second category we can do flow simulation. And the main objective here is to understand the flow distribution, temperature distribution, either it's over the object or inside the enclosure, with so many add-in and features are added specifically in SOLIDWORKS flow simulation. The third one is SOLIDWORKS plastic, and we are able to produce plastic injection molding parts, do the test prior to the manufacturing stage, and understand the defects. And the last bit we are talking about SOLIDWORKS motion, which is talking about mechanism design and understanding the power required, the energy required, and size of the motors and actuators. One very important note in this one, we do have rigid dynamic analysis. So the main advantage of using SOLIDWORKS simulation solution is its integration with this, let's say CAD. Well, as a user, you don't have to import or export and lose the accuracy of your, let's say, geometry. All of this module can communicate to each other by importing and exporting the, let's say, result. For instance, your flow result on the structure can be exported to FEA, and you understand the effect of flow on the structure in terms of deflection, strain, and stress. And obviously, you have a powerful, intuitive, and robust solver and software. All right, so let's specifically focus on our topic today, which is like SOLIDWORKS Simulation FEA side. And as you can see, we have a range of the capabilities and application within 3 different licensing. The first one is SOLIDWORKS Standard. Well, you are able to perform static studies for one instant of load. Then you can check the fatigue possibilities as the load is getting repeated. Obviously, we talk about motion, which is about mechanism design and finding the actuators and the motor size. And specific for today, we're talking about Trend Tracker. So in SOLIDWORKS Simulation Standard, we have an intuitive tool called Trend Tracker, which is available for evaluating the impact of successive design changes on the product performance. Means after you're running the first initial static simulation, you can start the Trend Tracker, make the initial analysis as a baseline design, and then you compare the successive design changes. So as a user, which you are performing freeform design changes, Trend Tracker automatically does all bookkeeping for you in terms of saving results such as weight, stress, displacement, or any other parameter that you want to track. All right, so with that quick introduction, let's go to the model and find out what we can do in practice. So I'm opening up my model. So today we are just talking about testing this simple part, which is a rod connector. And as you can see, I have my design tab manager here, and I can see the features, couple of extrusion, cuts, and sketches, chamfers, and etc., which I've built one single solid body. SOLIDWORKS Simulation is an add-in, means you have a base package at any level, and then since you have the license, you can go and activate it, and after that, you get the simulation tab here. And in order to create a study, you need to click on New Study. Again, depend on your license, you can perform different tasks or different studies. So today we are focusing on a base study of static analysis. Give it a name as you like. Click OK, and then you can see in a new tab, you are able to perform linear static analysis for the design you have made in a model tab. All right, so this is what we call full integration with the CAD. Now looking at the new tree we have in SOLIDWORKS Simulation here, specifically for this fall, we can see items coming after each other. That's simply giving us the idea what sort of steps we have to complete to create a simulation here. First of all, you can see your part name, connecting rod, and there is a material assigned to it. In order to do that, I just right-click and say Apply Edit Material, access SOLIDWORKS library of material, get my material, checking on the important parameters as highlighted by red, such as elastic modulus, Poisson ratio, or yield strengths, and apply. You have more options to have your custom material or download it from SOLIDWORKS Material Web Portal. So after completing this section, step, you can see a green tick, material assigned, and this is the base information we gave the software. In the next step, as you can see, we have to go for connections. Means if you have multi-body part or an assembly, we have to tell the software how they are interacting. Means are they bound together, can be separated, are they just passing through each other? So this kind of activities, this is called contact sets. Or if you have any connectors such as bolts, pin, and everything else, it is all going to be defined at this step. However, since we have just one single part, we don't have to do anything. On the next stage, we have to define fixtures, means the connection of our actual model to the rest of the board. And by right-click, we can see the list of standard options we have and also advanced option. Let's pick up any of them. And you can see in a standard, we have fixed geometry, we have roller slider, and we have fixed hinge. So very simple. I'm going to select this cylindrical face and make it as a hinge connection. You can see the preview of what hinge connection really means. So that is the first fixture I have. And also I know this is going to connect to the other part by a series of bolts. Therefore I'm selecting fixed geometry and I'm selecting two cylindrical face in here and make them fully fixed. Alright, so clicking OK, I have completed my definition of how this actual part is connected to the rest of the board. It could be the other assembly or the other parts we have in our big model. Alright, let's look at the next step. We go to external loads and again right-click will give us the options we have, such as force, torque, pressure, gravity, and etc. In this specific case, I would like to apply force, and then I'm going to my split face, selecting this one. Right now it's normal to the face as arrows are showing me the preview. However, I would like to make it directional. For that option, I need a reference plane, which could be one of those planes or anything else you have created in the model. So selecting that one, I can see the plane, and then say I would like this force to be normal to that plane, applying to that face. And the magnitude is 2220 Newton. One thing I have to check is direction of load. Right now it's tensile load. I would like to make it reverse and make it compressive. So simple as that, I have defined my load and I complete my problem definition phase. The last step before we see any result on the model is to perform one very important operation, meshing. Meshing simply means you are considering an element, which in SOLIDWORKS is look like a triangular shape, with the size of the element you're specifying, which could be a constant one or could be a variable one, and then you converting your CAD geometry to the network of these elements. Well, all the mathematical, let's say, equations are getting solved through this network, specifically at their join point, which we call nodes. Nodes are look like probes you put in a real test, let's say testing, and you're recording the result on them. All right, so we have complete our problem definition and we prepared our model to do the FEA study. Now it's the time to run this study. So we run this study and now we have three standard plots are coming, stress, 1 meters. which right now I have scientific option active on it, I can make a modification to show me not in Pascal, to in megapascal, and go to my chart option and say I don't like to have scientific presentation, I would like to make it general. And clicking OK, very clearly we can see we have the maximum stress of 15.7 megapascal in the model. We can rotate and have a look where it is. And one important thing we can see here, our yield strength means when the part starts failing is happening at 140 megapascal. Means our current design is very safe in terms of tolerating this force. There are more quantities we can check, such as how much is displaced. It is like 9.5 E minus 3 millimeter, and these are the values of strain. All right, so we've done the first or the base study here, and we found it is all good. The other thing we can, let's say, check about our, let's say, study is to define the factor of safety plot. And this is basically the ratio between how much load you applied and how much the actual part or component can tolerate. Right now, if I go for chart option and activate maximum and minimum tags to be shown, I can see my factor of safety is around 8.9. Simply means this rod design can tolerate nearly 9 times more than what I'm applying in terms of load. All right, so with that one, now I'm just start to considering it might not be the best design. It's as that this design could be very costly and could be very heavy. Now I would like to introduce some mass reduction, and at the same time I would like to look at the stress value and make sure I'm doing some optimized design here. So for that reason, what I have to do is very simple. As a feature of SOLIDWORKS Simulation Standard, you can always go and right-click on your study name and activate the trend tracker. If you're doing so, your tree will show with the trend tracker item, and there is a trend journal. We'll be recording all the changes from this point forward. So what we have to set at the beginning is to right-click and set this study as our baseline. So initial iteration or the baseline of the iterations. By doing so, what is happening? All the current results are going to be recorded on our trend journal, and you can see there are some graphs being generated here, such as a mass. On our first iteration, which is the baseline, we have the mass of 259 around. And same for the stress. And same for displacement. So these are the charts which contain some specific data, and we would like to introduce the changes and later on look at the variation on these charts. Now you might have a question, is that generated automatically? Can I add more, or can I delete anything from it? The answer is obviously yes. Where we can do this is basically we have to go to the Model tab, and in order to trace any specific parameter in SOLIDWORKS, you need to have a sensor for it. And if you look at this design tree, sensors are listed here. Right now, as you see, so the list, I had the mass, stress, and displacement sensor, and I would like to add one more sensor. So add sensor and select the type, which is mass properties, simulation data, dimension, measurement, or costing data. In this case, we're selecting simulation. Data quantity could be stress, strain, displacement, frequency, thermal, velocity, and etc. Depends on the type of a study you have. So I'm selecting stress. I had a sensor for 1 meses, and this time I'm going for a triaxial stress values. And then I can decide about the unit, which is megapascal, to trace the maximum triaxial stress over the whole model, minimum of it, or average of it. or going for maximum over a specific entity such as this face or that feature or anything else. Let's focus on model max. So by clicking OK, you can see I have created stress 2 sensor here. Now let's switch back to my baseline study, which is a static 1. And right click on the trend tracker. You can see I can add track data graph. List of my sensors are here. I have recalled mass 1, stress 1, and displacement 1 before, and now I can add stress 2. And simply I have 4 graphs and 4 trend trackers, let's say sensor, on my study. All right, so now I'm ready to start design changes. And since I have the trend tracker, all the changes will be recorded in my trend journals and graphs here. All right, what I do, first I'm thinking about my dimensions here and selecting that 16 millimeter thickness and make a change to 14. Click OK. As long as you do that, you can see your simulation will have some warning on the study name, on the mesh and result. Means the model is changed and we have to update or rerun the simulation. So let's run this study. We're doing this. All right. All right, so it's recording this one. I might need to, let's say, rerun. Let me do this one. Delete one of my iterations, doesn't really matter, yes. And I can rerun this study. All right, solving it. Perfect, done. What I can see, my trend tracker is showing me iteration number 2, and what is happening, I can look at a new stress value. I reduce the thickness, I've got stress increased from 15 to 17.8. That is the first thing I can see. Second, I can check my factor of safety. From nearly 9, it is now 7.86. That is what I'm expecting. Less material and it is weaker part, but still this factor of safety is very good. Let's to be very specific and look at how much mass reduce. So we were around 260 grams, and with that design change, I've reached 226 grams. All right, I made one step forward, and it is reducing the mass and obviously the cost, but still I think it is very heavy. My stress are not really high, and I have very good factor of safety. Then I'm going to the next stage. I would like to, let's say, remove more material on this model. So for that reason, I have a sketch here, and I would like to convert it to a cut extrude, where it's going to be through all on the first direction and through all on the second direction. Clicking OK, I have cut this slot on my run model. Now I would like to see what are the new stress value and how much mass is being reduced. I'm getting back here, and again I have to rerun the study. So running it, completing, and now I have the option to look at the stress. Interesting. From 17, it jumped to 32. And one very important factor of safety from 7.8 is now 4.3. It could be very critical. And it might not be my, let's say, desired factor of safety for my design. Therefore, I might think of the third change as, let's say, if I would like to add a bit of material and make it more structurally, let's say, stable. But before we doing that, let's look at our trend tracker. My mass is significantly reduced from 225 to around 150 grams. That is a huge mass reduction. But at the same time, my stress values are nearly doubled, from around 17 to around 32. Okay, so I would like to make another attempt, another iteration, and for that reason I'm getting back to my model, and selecting the appropriate plane as I like this plane, and making a sketch on this plane and basically convert what I cut here to an entity. And then I'm adding, hang on a minute, I've made a mistake, sorry guys. Let's say select this plane, let's create a sketch and select that contour to convert to entity. Now it's working okay. Now let's get back to my features, make it boss extrude, and this time instead of blind, I'm going to midplane and make it as 4 mm on both sides. So that is how much material I would like to add here. Alright, so clicking with that one, it's okay. Coming back to my studies, and obviously it's got the warning because it's new, and simply running the study here. Now what I can see initially, from 32 I'm down to around 20. That is a very good stress reduction. Look at factor of safety, very good, 7.18. Now the only question remaining, I nearly doubled my factor of safety and let's say significantly reduced the stress. Now what is my mass increase value? From 150 gram, I'm reaching to 172. It's a bit more than 10%, but nearly my factor of safety is getting doubled. So that's looked like a very successful, let's say, approach. So the initial thinking of removing the whole thing and cut through the whole material was not a great idea, and this is how it should be. Now you can go more and more and extract more, let's say, material from the other components, changing dimension and making sure you're fixing one of your variables to achieve the best one in your design. Alrighty, so with that one, you can see all your iteration is being saved, and you can restore your model in any iteration, like the baseline, like in iteration 2, iteration 3, as many as you like, and trace. Obviously, you can go and look at the mass changes, also save all this graph or print them. Okay, and in each study or iteration you have your 3D result presentation to understand the distribution of all these properties. Alrighty guys, that's all we can say about Trend Tracker. It's a very handy tool, and let's go and have a quick review about what we have learned today. And let's get back to here and go to Trend Tracker. What we can do and what we do have in Trend Tracker. A trend journal list, detail about the baseline and every iteration. We have a graph to show the trend in important result quantities. View one of the default graphs or add a track data graph. We have a gallery showing displacement and stress plots for every iteration. We have a rollback function which allowing us to restore the model to a specific iteration, and we can add iteration automatically or manually when you're running studies or design scenarios. I hope this webinar was informative and useful for you guys. If you have any commercial discussions, you are more than welcome to contact John Belsham. He's a Simulation Product Manager Sales, or if you have any technical information required, more presentation, and we can assist, like to have an assistant in the technical side of the software, please feel free to contact me, Esfandiar Kuhi, and we hope to see you in the next sessions. Have a good day. Bye.